the humidity or the rain. I'm sure, I think Becky, you mentioned some ways to make it waterproof, your microphones, but
yeah, so one of the things that we do is we have those vents that I mentioned, and it's basically like an expanded PTFE, which has pores in it that the air can get through fine, but water droplets get stopped by. So we use those to kind of minimize how much water actually gets into the device, but also with things like condensation and just general like humidity in the air, we do have some issues there too. So little, like silicon packets that you get in, I don't know, things that you buy. You can buy a big bag of silicon packets for a couple of pounds, and we throw a few of those in each of the recorders. And that seems to keep the humidity and the moisture under control quite well.
But that lasts for a while only. I guess if you have very, very humid, and even though it's a big bag, at some point you have to change it.
Yeah, I mean, we've had stuff out for, so the stuff that's been out in Borneo has been out for in the region of a year now. Maybe there was 6 months continuously, and I think it might be up to a year continuously before they had any issues. One of the big problems we had actually was more to do with animal damage. So if things like monkeys and elephants would notice them as something abnormal, and there was quite a lot of literal like forceful damage, and ants as well would sometimes get into like chew away at the silicon and stuff like that. So to be honest, I would say the animals probably got to it before the humidity did, but yeah, there is a lifetime on it for sure.
I see some activity in the chat. Guillaume Dutier is saying, do you want to come up and talk, Guillaume?
Yes. Okay, I'm not sure it's. Can you hear me?
Yes.
Yes, I'm not sure it's completely relevant, but we have some experience here at NTNU with homemade development. The purpose was not immediately bioacoustics, but I think what we developed could be of interest for other people. Actually, we worked on the possibility to synchronize several devices based on Raspberry Pi to do acoustic recordings, and more specifically impulse response measurements, something that could be interesting if you want to know the attenuation between one point and another. I think that's relevant when estimating the active space of a species, for instance. But we, since it was in the framework of a master thesis, we couldn't completely complete the project. But what we achieved, at least, is developing a dedicated hat, as it's called. So it's an additional board for the Raspberry Pi that can accommodate for two 48-volt microphones. If you're interested in high quality recordings in the field, it can be interesting for you. If you just want to power electret microphones, it may not be so relevant.
And so this type of microphone would be more for short-term, good quality recordings, or can you leave that?
Well, yes, I think that you can deploy such a microphone in the field for a long time, and there are suitable weather protections for such microphones. But it's clear that it's expensive equipment, so you must have a good reason for that. If you search for species that produce very quiet sounds, or if you want to have a very high signal to noise ratio, it can be useful.
And you think it's mainly because it's expensive that people are not using it, or is it?
Well, yes, I think so. And it's also less compact. Electric microphones can be a few millimeters in diameter, whereas typically the 48-volt microphones are the format. The 48-volt standard is for studio, sound reinforcement, and such applications, or for the people who do nature sound field recording. They will use that kind of microphones and not electret microphones because of their higher performances.
So one question for Betty. How far are we from having processing compiling the sensors? So for example, your sensors registering direction and intensity of the signal instead of saving the 6 microphones and having everything processed later on in the computer.
So was that how far away from having that process fully automated are we?
So my question is, how far are we from having pre-analysis compiled directly in the sensor deploy? Like for example, the 6 microphone sensor processing and sending directly the direction and intensity of the signal instead of the register of the 6 microphones and then having to process everything on the computer?
Yeah, so that's actually that was something we spoke about quite a lot early on, because obviously if we just send like the metadata or like the data that's held within the signals to our servers, that's obvious that will take up a lot less bandwidth and a lot less. Yeah, it will cost a lot less for us to send and store, but we decided against that in the end because sending the raw audio allows us a lot more flexibility with the analysis. Whereas if we do all of the computing on board the Raspberry Pi and just send the data, we're kind of limited to just doing that for the foreseeable. And say someone else comes in and is like, oh, I'm looking for something slightly different, we're then not able to share that data set with them, if that makes sense. We can only share them the analysis that we've done. So for the time being, while we have a large amount of cloud space and more than enough room to store this data, then we kind of want to keep it in its rawest form while we can still do that. There is, I mean, you'll see if you look at the GitHub and the code that runs the Raspberry Pi, there is definitely availability for you to sort of like plug in your analysis. If that's what you want to get sent, then that's definitely available. That's definitely something you can add in. But for our purposes, we decided to just keep it with the raw audio.
There was a question about the relative performance of electronic mics versus high resolution microphones. Maybe, yeah, Becky, if you know, or Guillaume.
Yeah. So the first device that I explained, like that I spoke about, used a high quality microphone. So that had a sampling frequency of 48 kilohertz, and the audio quality we got out of it was very good. In terms of the MEMS microphones that I've used in the device that I've got, there's definitely a noticeable quality, aside from the fact that you're losing any frequency above, we can't record anywhere above 8 kilohertz, but also the quality of the signal below that is the bit depth is much smaller. So there is a definite loss in quality, but I think for the analysis we're trying to do, it was more to see if we can get that. The kind of height dynamic stuff is more the question that we're asking. To be honest, I haven't directly compared data from the high-res mic to the data we're getting out of the recorder I'm using. But I think that would be quite interesting to see how that affects things like the analytical indices. Definitely.
would you expect it would affect also active space of the microphones? Like, is the signal to noise ratio better?
Yeah, so definitely in the MEMS microphones that I'm using, there's definitely a lot more noise. So before the analysis that I've been doing at the minute, I'm putting like a high pass filter on all of it because we've got a band of noise between around like 1 to 2 kilohertz. It's just like constant. Something that we're not really dealing with the high quality microphone. So yeah, I mean, I would say there is definitely a drop in quality that I've seen.
Yeah. But I guess it's always a question of how, like, what is enough to work with, right? And
yeah, and so the microphone that we used in the first one, I think just the one microphone cost in the region of like 40-50 pounds, which that whole 6 microphone array cost 40 to 60 pounds. Additionally as well, so I did a load of like battery and like power consumption tests, and the one mic used as much power as the 6 mic. So while we have sort of taken a loss in quality per individual mic, it's meant that we've maintained the price and the power usage at a kind of reasonable level.
Okay, well, we could probably stop there. Because in France and other parts of the, they are having regular time for.
If anyone has a last comment, feel free to raise your hand. Otherwise, we'll close this open discussion. Thanks again to Becky and Laura for presenting, and thanks to you all for participating in the discussion. It was really interesting. And
See you this afternoon.
yeah,
Thank you.
at 3 European time for those who want to join for the third session. And thank you.
Thank you.